Welcome to doassignment-ca. Here is the problem. An air spring is used to protect a support and prevent damage to a tensioning weight in the event of a belt failure. The force developed by the air spring as a function of its deflection is linear. The force increases from 0 newtons at s equals 0 meters to 1500 newtons at s equals 0.2 meters. A block of mass 20 kilograms is suspended at a height d equals 0.4 meters above the top of the undeformed spring. Determine the maximum deformation S max of the spring when the belt fails. Neglect the mass of the pulley and belt. Now let's work through the solution step by step. From the graph, the air spring force increases linearly with deflection. At 0.2 meters, the force reaches 1500 newtons, giving a spring constant of 7500 newtons per meter. We place the gravitational potential energy datum at the top of the undeformed spring. The block starts 0.4 meters above that point and comes to rest momentarily after compressing the spring by S max, having descended a total distance of d plus S max. Since the block starts and ends at rest, the total work done on the system equals 0. That means the work done by gravity plus the work done by the spring must sum to 0. The gravitational work equals the weight times the total downward displacement, which is the initial drop of 0.4 meters plus the spring compression S max. This gives 196.2 times the quantity 0.4 plus S max in joules. The spring exerts an upward force on the block while it moves downward, so the spring does negative work. Integrating the linear force over the deflection gives negative 1/2 times k times S max squared, which equals negative 3750 S max squared joules. Substituting both work expressions and setting their sum to 0, then expanding and rearranging gives the quadratic equation, 3750 S max squared minus 196.2 S max minus 78.48 equals 0. Applying the quadratic formula with A equals 3750, B equals negative 196.2, and C equals negative 78.48, we substitute into the expression S max equals negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. The discriminant equals 38,494.44 plus 1,177,200, which equals 1,205,694.44. Taking the square root gives approximately 102.59. So S max equals 196.2 plus or minus 102.59, all divided by 7,500. The two roots are approximately positive 0.173 meters and negative 0.121 meters. We discard the negative root since spring compression must be positive. Therefore, the maximum deformation of the air spring is approximately 0.175 meters. We verify that 0.175 meters is within the 0 to 0.2 meter range shown in the graph, confirming the linear spring model is valid. Checking the energy balance, gravity does about 112.8 joules of work, and the spring absorbs approximately the same amount, confirming the answer. The maximum deformation of the air spring is approximately 0.175 meters. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.